Welcome to Cosmos in a Pod Space and Astronomy series, episode 13. Today we're going on a deep dive into a force that's been shaping our universe since the very beginning. Gravity. Get ready to uncover the mysteries of this invisible force, from why things fall down, to the ground, to how it sculpts galaxies, even creates those crazy black holes. So let's start with the basics. What exactly is gravity? I mean, we experience it every day, but what's the science behind it?
Gravity is one of the fundamental forces of nature, and it's all about attraction. Any two objects with mass, they pull towards each other.
Like me and this giant burrito I'm about to devour.
Exactly. But on a much larger scale, right, you and the Earth are constantly pulling towards each other.
Oh, okay.
The Earth, being much more massive, wins that tug of war,
Right.
which is why you stay grounded.
Okay, so that explains why things fall down. But I remember learning about, Newton's apple and his law of gravity. How does that fit in?
Newton's law of gravity, that was a huge breakthrough.
Yeah.
He figured out that the strength of this gravitational pull, it depends on two things. The mass of the objects and the distance between them. The more mass of the objects and the closer they are, the stronger the attraction.
So a bowling ball would have a stronger gravitational pull than a tennis ball.
Precisely. And the closer you are to an object, the stronger its pull. That's why you feel Earth's gravity more strongly than the sun's, even though the sun is like way more massive.
Makes sense. But didn't Einstein come along and kind of, change our understanding of gravity with his theory of relativity?
He sure did. Einstein took our understanding of gravity to a whole new level, yeah.
Mhm.
He said that gravity isn't just a force, but a warp in the fabric of space-time caused by massive objects.
Hold on. Warp in space-time. That sounds a bit like, science fiction.
I know. It's mind-bending. Think of it this way. Imagine a stretched out sheet, like a trampoline. If you place a bowling ball in the center, it creates a dip. That's similar to how massive objects like stars and planets warp space-time.
So smaller objects are drawn towards those dips.
Exactly. It's not that objects are, like, attracted to each other in the traditional sense. Instead, they're following the curves in space-time created by these massive objects.
The gravity's more like following a cosmic roadmap than being pulled by an invisible force.
That's a great way to put it. And this warping of space-time is what causes those familiar effects of gravity, like objects falling to the ground or planets orbiting stars.
Okay. I think I'm starting to wrap my head around that. But let's zoom out a bit. How did gravity shape the early universe after the Big Bang?
Well, imagine the early universe as this hot, dense soup of particles and energy. There were tiny random fluctuations in the density of this soup.
Like little clumps in the cosmic soup.
Exactly. And over time, gravity acted on those clumps, pulling more and more matter towards them. It's like those tiny clumps acted as seeds for the formation of the first stars and galaxies.
So gravity was kind of like a cosmic sculptor, shaping the universe into the structures we see today.
That's a great analogy. But there's another key ingredient in this cosmic recipe: dark matter.
Dark matter. The universe's biggest mystery. What does that have to do with gravity?
Dark matter is a mysterious substance that we can't see directly, but we know it exists because of its gravitational effects. It's like an invisible scaffolding that helped gravity pull matter together in the early universe.
So even though we can't see it, dark matter played like a crucial role in shaping the universe we see today.
Absolutely. Without dark matter, galaxies wouldn't have formed as quickly or in the same way. It's a testament to the power of gravity and the unseen forces at work in the cosmos.
This is incredible. So gravity is responsible for bringing all this matter together. But how does it actually ignite stars? I mean, what makes them shine?
Imagine those giant clouds of gas and dust we talked about earlier. As gravity pulls them inward, those clouds start to collapse under their own weight.
So it's like squeezing a giant cosmic balloon.
Sort of. As the cloud collapses, the pressure and temperature at its core increase dramatically. Eventually, it gets so hot and dense that nuclear fusion ignites.
Nuclear fusion. That sounds intense.
It is. That's the process where hydrogen atoms fuse together to form helium, releasing tremendous amounts of energy in the process. That energy, that's what makes stars shine.
Wow. So gravity is not only a sculptor, but also a star maker. It triggers this incredible process that powers the stars. But what about the life cycle of a star? Does gravity play a role there too?
Absolutely. Gravity's a key player in the entire life story of a star. From its birth to its eventual demise. a star's mass, which determines its gravitational pull, dictates how it will live, how long it will shine, and how it will eventually, die.
So a star's fate is sealed from the moment it's born, all thanks to gravity.
You got it. It's like gravity sets the stage for this incredible cosmic drama. Now let's shift our focus to something a bit closer to home. Our solar system. How does gravity keep everything in order here?
Our solar system is a beautiful example of gravity's orchestrating power. It's the reason why planets, moons, and asteroids all orbit the sun in a delicate balance.
So it's like a cosmic ballet with gravity as the choreographer.
Exactly. The sun's immense gravitational pull keeps all the planets in our solar system bound to it, influencing their orbits and movements.
But it's not just the sun calling the shots, right? Don't the planets also influence each other? You're absolutely right. While the sun's gravity is the dominant force, the planets also exert their own gravitational pulls on each other. These interactions between planets help stabilize the entire system over billions of years.
It's like a giant cosmic mobile with everything perfectly balanced, thanks to gravity.
Yeah.
But I have a feeling gravity's influence goes even further, right? Beyond our solar system.
You're on the right track. Gravity's reach extends far beyond our solar system, shaping the vast structures of galaxies and even influencing the fate of the entire universe.
This is blowing my mind. I can't wait to dive deeper into those cosmic mysteries. But before we get lost in the vastness of space, let's take a quick pause. When we come back, we'll explore how gravity shapes galaxies, unravel the mysteries of black holes, and even ponder the ultimate fate of the universe. Stay tuned. Welcome back to Cosmos in a Pod. We've been on quite a ride exploring the power of gravity, from, falling apples to the birth of stars, but now let's venture even further into the cosmos and see how this fundamental force shapes galaxies and beyond.
Galaxies are these vast, vast collections of stars, gas, dust, and of course, dark matter, all held together by, you guessed it, gravity.
Oh, even on a galactic scale, gravity is the glue that holds everything together.
Absolutely, but it's not just about holding things in place. Gravity also sculpts galaxies into those stunning shapes we observe.
Okay, so how does gravity turn like a giant cloud of cosmic ingredients into these magnificent structures?
Well, let's start with, spiral galaxies, like our own Milky Way. Imagine a giant disk of stars and gas rotating, gracefully in space. Gravity, it pulls everything inward, while the rotation, it flings things outward, creates a delicate balance that leads to the formation of those iconic spiral arms.
Like a cosmic dance floor, with gravity setting the rhythm and the rotation adding a twirl. But what about those galaxies that aren't spirals?
Right, right. There are also elliptical galaxies, which are more rounded and less structured than spirals. These often form from the collision of two or more spiral galaxies.
Galactic collisions. That sounds intense.
They are. Imagine two galaxies, each with billions of stars drawn together by their mutual gravitational attraction. As they get closer, their shapes distort. Stars get flung around, and eventually they merge into a single, more massive elliptical galaxy.
So gravity is not just a sculptor; it's also like a cosmic matchmaker, bringing galaxies together in these dramatic mergers.
Exactly. And the story doesn't end there. Gravity connects galaxies into even larger structures called galaxy clusters, which contain hundreds or even thousands of galaxies bound together by their mutual gravitational attraction.
Wow. So we have galaxies, then clusters of galaxies. Is there an even bigger picture to this cosmic tapestry?
There is. Zoom out even further, and you see that gravity has woven these galaxies and clusters into a vast cosmic web, a network of filaments and voids that spans the observable universe.
So gravity is responsible for organizing matter on a truly mind-boggling scale.
Yeah.
It's like the architect of the cosmos. But now I have to ask about the most extreme expressions of gravity. Black holes.
Black holes. These are regions of space-time where gravity is so strong that nothing, not even light, can escape. They're like cosmic whirlpools, warping space-time to an extreme degree.
They sound a bit terrifying. How do these gravity monsters form?
Black holes form when massive stars collapse at the end of at the end of their lives. All that stellar material gets squeezed into an incredibly small space, creating a region of immense density and gravitational pull.
Okay, so if nothing can escape a black hole, how do we even know they exist?
We can't see black holes directly, but we can detect their presence through their effects on their surroundings. For example, we can observe stars orbiting around a seemingly empty space, which indicates the presence of a massive unseen object, a black hole.
So it's like their gravitational signature gives them away.
Precisely. And then there's another incredible phenomenon that confirms the existence of black holes, gravitational waves.
Right. I remember we touched on those earlier. Remind me what those are all about.
Imagine two black holes spiraling towards each other and eventually colliding. This cataclysmic event sends out ripples in spacetime, like waves spreading from a stone dropped in a pond. Those are gravitational waves, and they carry information about these violent cosmic events across vast distances.
So we're essentially listening to the universe's most dramatic events thanks to these gravitational waves.
That's exactly right. Detecting these waves was a huge breakthrough, providing direct evidence for the existence of black holes and confirming Einstein's predictions from over a century ago.
This is incredible. We've gone from apples falling from trees to the mind-bending reality of black holes and gravitational waves. But there's one more big question I have to ask. What do gravity tell us about the fate of the entire universe?
That's the ultimate question, isn't it? Will the universe keep expanding forever, or will gravity eventually pull everything back together in a big crunch?
I guess we need to consult our cosmic crystal ball.
Well, it's not that simple. The answer depends on the ongoing cosmic tug of war between gravity and another mysterious force, dark energy.
Right. We talked about dark matter earlier, but this is dark energy. What's the difference?
Think of dark matter as invisible scaffolding, adding to gravity's pull and helping to shape structures. Dark energy, on the other hand, is a force that seems to oppose gravity, causing the expansion of the universe to accelerate.
So it's like a cosmic battle
Yeah.
between these two forces. Who's gonna win?
That's the big mystery. The fate of the universe hangs in the balance. If dark energy continues to dominate, the universe will likely keep expanding forever, becoming colder and darker over time. But if gravity eventually wins out, it could slow down the expansion and eventually lead to a big crunch where everything collapses back in on itself.
Wow, that's heavy.
Yeah.
So the future of the universe is still an open question, a cosmic cliffhanger.
Absolutely. There's still so much we don't know about dark energy and the ultimate fate of the universe. But one thing's for sure, gravity will continue to play a key role in this cosmic drama, shaping the universe for billions of years to come.
This has been an amazing journey through the world of gravity from the everyday to the truly mind-boggling. But before we get lost in the vastness of space, let's take a quick break. When we come back, we'll wrap up our exploration of gravity and leave you with some final thoughts to ponder. Stay tuned. Welcome back to Cosmos in a Pod. We've been on quite an adventure, right? Exploring this incredible force of gravity.
Yeah, we certainly have. I mean, from its role in, shaping galaxies to its influence on the fate of the entire universe, gravity is truly a force to be reckoned with.
So as we wrap up our deep dive into gravity, what are some key takeaways that you think our listeners should hold on to?
Well, I think the most important takeaway is that, gravity's everywhere, right? And
Wow.
it affects everything. It's the invisible force that shapes our everyday experiences, like the way objects fall to the ground. And it also governs the grandest cosmic events, like the formation of stars and galaxies.
It's amazing to think that this one force connects us to to the entire universe,
Yeah.
from the smallest particles to the largest structures.
Exactly. And another crucial point is that, our understanding of gravity, it's evolved over time, right? From Newton's groundbreaking laws to Einstein's revolutionary theory of general relativity, scientists have, they've continuously refined our grasp of this fundamental force.
And with new discoveries, like gravitational waves, we're still learning more about gravity and its incredible effects.
Absolutely. The study of gravity is a journey of ongoing discovery, and each new finding, it opens up even more questions and possibilities.
So gravity is a story that's still being written, a cosmic mystery with many
Yeah.
chapters, yet to be revealed.
That's a great way to put it. And what makes it so fascinating is that, it leads us to ponder some of the biggest questions about existence, like how did the universe begin? How will it end? And what is our place in this grand cosmic scheme of things?
Those are some truly profound questions that that remind us of the vastness and the wonder of the universe.
I think that's a perfect note to end on. Gravity it isn't just a force. It's a reminder of our connection to the cosmos, a testament to the elegance and the mystery of the natural world.
So the next time you feel your feet planted firmly on the ground, or gaze up at a star-filled night sky, take a moment to appreciate the invisible hand of gravity at work. It's a force that shapes our world, our galaxy, and our entire universe. Thanks for joining us for this cosmic deep dive into the world of gravity. We hope you've enjoyed exploring this fundamental force with us. If you'd like to continue your exploration of the universe, don't forget to follow and subscribe to Cosmos in a Pod for more exciting adventures through space and time. Until next time, keep looking up and keep those questions coming.
Yeah.